Okay, welcome everyone to another search seminar. Weixuan, you have 50 minutes, take it away.
Thanks for Daniel to introduce me to the talk. I will share the screen. So I'll make it full screen. Just to make sure, can you see my full screen? Okay, great, thank you. So now let me start the talk. Before I move to the before I start the talk, I will say something about the about the weather conditions here, because there's a typhoon in Hong Kong just outside my door, so there might be some noise or internet disruption during the talk, which might be beyond my control. So I apologize in case that any adverse event happened during the talk, and I will try to make it as smoothly as possible. So now let me start the talk. The title of our talk is Indirect Sales with Search Costs. This is a joint work with Zhou, who is also a fellow PhD student at Hong Kong University of Science and Technology. And I myself I'm also a PhD student at HKUST. And let me start the talk. So we would like to motivate our talk by introducing two examples. So the first example comes from the tourism industry. Just observe that here's a sentence that I highlighted in this advertisement. You may need lunch before or after visiting a Temple Palace, which is a place of interest in Beijing. But the lunch fee is on our own side. But no worries, it will cost about $7 per person at your own cost. So this is how the tourism example works. The tour guide will actually guide visitors to a particular restaurant, but participation or purchasing at that restaurant is completely voluntary. Consumers can eat at that restaurant conveniently, but if they would like to eat at somewhere else, then they will need to depart from this restaurant, going into the other restaurant, and after they finish, they'll still need to come back because the car is parked there. So it involves some kind of cost if they decide to visit the restaurant that is not recommended by the tour guide. But that cost is absent if they visit the restaurant that is just nearby. And another example comes from the online platform, where the two drugstores selling the homogeneous product on this online platform. So they differ in ratings, distance, price per unit, and they are the same in other aspects such as minimal purchase per order, delivery fee, delivery time, or mode of delivery. The drugstore one has a lower rating, longer distance, and higher price per unit than the drugstore 2. However, the drugstore one was recommended by the online platform to consumers. And indeed, we observe a significantly higher purchase for consumers to drugstore 1 than to drugstore 2. So we would like to explain this kind of phenomenon in our model as well. There are two important features of the day tour example. The first one is that travel agencies have some degree of market power. In fact, tour guides can effectively guide visitors to a particular restaurant. Another feature is that consumers would incur a search cost if they would like to eat from a restaurant not prioritized by the tour guide, because they need to leave the restaurant, enter a new one, and get back to the restaurant in order to depart to the next place of interest. And the e-commerce platforms have a similar story. Unicorns such as Amazon and Taobao have a stronger market position than merchants do, and consumers will need to scroll down with their mouse or click on the next page in order to buy from a merchant that did not show up as the first search result. Here is where the search cost involved that is related to the content of our consumer search digital seminar series. So in this paper, we propose a model of indirect sales with search costs. Specifically, we consider the case where two merchants selling a homogeneous product compete via a sales intermediary. The timeline is as follows. So it involves 3 stages competition. In the first stage, merchants simultaneously submit their prices to the sales intermediary. And after that, the sales intermediary ranks the merchants and displays both prices according to the rank to consumers. Lastly, consumers with unique demand decide whether and where to buy a product. So our key assumptions, our first key assumption is that consumers know the prices of merchants before their visits. So this is how our paper departs from the classical framework, such as the Variant 1980 and the project the Zhou 1983 and Stall 1989. In their framework, consumers would need to pay search costs in order to obtain the prices of the other merchants. But in our paper, we assume that consumers costlessly observe both prices. So this assumption captures the advancement of online search technologies that enables consumers to costlessly obtain the prices of products both online and offline. We justify this assumption by illustrating 2 examples. The first example comes from it's related to the offline stores, in that reviews on the popular websites such as trip.com provide interested visitors with the prices and characteristics of the products in restaurants and souvenir shops, such that the visitors could conveniently identify these prices and characteristics before they do the actual visits. As for the online platforms, they actively advertise the latest updates of product information on their websites, so that consumers can also conveniently identify the latest information related to prices of the products that would like to buy. Another
Can I ask a question here?
Yes, please.
So I agree that somehow these technologies typically make it less costly to observe prices than maybe some other characteristics. But probably it's not the case that actually this means that you can get all the prices that are relevant for free. So there is still probably a small search cost that is relevant. And we know in the consumer search literature that even if the search cost is small, it might have still tremendous impact on market outcomes. So to say that the search cost is small is not the same as to say that it is zero and that consumers know all the prices. And so quite a bit of the motivation that you seem to have is more that these costs are relatively small rather than that they are zero. And so is it really important for the results that the consumers know the prices, or?
So to answer this question, basically our model focuses on the search costs if they on their visits rather than to identify the different price quotes. So that's our focus. So we made some simplification on the other aspects. So here we just abstract away the search cost to identify the prices. But yeah,
but I mean, so if I'm close to the if I'm in Beijing and I have to look for a restaurant, and the price is probably, it cost me still quite a bit of effort to see which prices are relevant in that neighborhood. But then, anyway, I mean, I know that there is some literature now that assumes that consumers that they know the prices before they search. But I think it's a given that that small search costs might be very different from zero search cost, I think it's still a leap to say that they are zero.
So I guess having a search cost to identify the prices could be an extension for our current work, because our work so far we just assume this aspect. We assume away the search cost in this dimension, and we already obtained some results that are that differ from the classical frameworks. So I guess if we add that additional aspect, we're not sure whether they will gain additional insight into our model. But yeah, we haven't done that. But we
please carry on. I mean,
that's not so far. That's not our key focus. So we just abstract away for simplification. And it's great if you have any like papers that have justification on the costless search. Then it would be grateful if you could let me know, and I will see whether they would be better examples to motivate our work. Yeah, that's great. So thank you. Let me just continue. So another key assumption in your paper is that consumers do not need to incur a search cost if they buy from the merchant that works first, but would incur a non-negative search cost if they would like to buy from the other merchant. But in this part, we are a little bit more general because we allow for the search cost to be zero. So this could capture the case where all consumers are deal hunters. This might happen, for example, in the tourism market where it's off season and every tourism is seeking for the cheapest one among the available choices. And it's also applicable to the e-commerce businesses on, let's say, a Black Friday in US or Double 11 in China, where every consumer is eager to identify the cheapest available option from the massive products online. And we assume that the sales intermediary charges a fixed and exogenous proportional fee to a merchant whenever a consumer buys a product from that merchant. So we'll talk a bit more about the exogenous assumption later. But for the proportional fee assumption, we can relax it in the extension. In our main part, we just assume the proportional fee scheme, but we can do it in a per unit. So this table summarizes our main results. Basically, the equilibrium can be characterized in three different scenarios. When the search cost is zero, then the unique pure strategy equilibrium is the competitive equilibrium. When the search cost is sufficiently large, then the unique pure strategy equilibrium is the collusive equilibrium. These two findings are similar to are analogous to the framework of the Bertrand and Diamond, respectively. But what's new in our model is that we find that when the search cost is positive and not too large, then there's no pure strategy equilibrium. This is something new, and we would like to do a little bit more work on it. So we find something more. When the search cost is intermediate, there exists an equilibrium in which merchants price either around the consumer valuation or around the consumer valuation minus the search cost with fixed probability. So we find that price dispersion can be generated without heterogeneous consumers or merchants. Everything ex ante identical, but still price dispersion can be sustained. And perhaps surprisingly, in this equilibrium, a higher search cost will benefit consumers but hurt the merchants and the intermediary. So a finding that is not new, but still has is somehow counterintuitive. The intuition of our results is that in the mixed strategy equilibrium, a merchant will randomize around the monopoly price and around the monopoly price minus the search cost. When the search cost increases, the amount of undercut needed for a merchant to get a recommendation from the intermediary and still all the consumers from its competitor will also increase. In equilibrium, all consumers will buy from the recommended merchant, and the probabilities assigned to the two prices remain unchanged, which means that each merchant's profit will decrease. Given a proportional fee scheme, the intermediary's incentive is perfectly aligned with the incentive of each merchant, meaning that the intermediary's profit will also decrease. And finally, observe that the social welfare remains unchanged. That would imply consumers must be better off. We will explain a little bit more about the intuition when we move into the formal model. So since there are many experts in consumer search here, maybe I will just briefly talk about the literature review. And in case it is not complete, just let me know if you have other new works that might be relevant to our paper. So our work is broadly related to price dispersion and ordered search, both theoretically and empirically. Classical works on price dispersions include Varian 1980, Burdett at June 1983, and Stone 1989. Their key elements are costly pricing information and heterogeneous consumers. In these two aspects, we differ. And there's some empirical work on price dispersion as well. So we just cite a few, which is definitely not exhaustive. And our work is also related to ordered search. The pioneer one is Armstrong, Vickers, and Zhou 1989, followed by Armstrong 1917. So the key elements in their work is that they assume exogenous search orders and heterogeneous consumers, whereas we endogenize the search order as a result of the profit-driven intermediary, and we allow for consumers to be homogeneous. Any question? I see someone unmuted you, so I hope I pronounced right.
I have a small comment, but not like a substantial thing. I think in the model of Burdett and Judd, the consumers are homogeneous, ex ante homogeneous consumers.
Sorry.
So in the model of Burdett and Judd, in their non-sequential search framework, the consumers are ex ante homogeneous.
So you mean in this paper? Oh, okay. So yeah. Okay, thank you. Maybe I will take a closer look at this, and in case there's any mistake, I will just correct it. I'll mark it down. So our paper is there are also empirical work on ordered search. Of course, this list is also not exhaustive as well. So I see both Martin and Sandro here. So I would they have a work that have a similar finding to us. Their paper on the search with a vertical structure. But basically, they also find that consumers can benefit from a higher search cost, but the mechanisms are different. So in their paper, consumers are unaware of the wholesale price charged by a monopoly manufacturer to retailers, and they find that total industry profit increases with the search cost. Whereas we assume that consumers have perfect information about the cost structure between the merchants and the intermediary, and in our framework, the profit of the intermediary is perfectly aligned with the profit of the merchants. So our paper is also relevant to the work on indirect sales with recommendation by Inders and Ottaviani. So in their paper, they assume that consumers are initially unaware of the product information, and that the intermediary cares about the consumer utility in the first order sense. Whereas in our work, we just assume that the intermediary is profit driven and only have some second order incentive on other parties' welfare. And our work is also related to studies on platform fee schemes and broadly on price competition. So let me introduce the model. In the main model, we assume that there are two ex-ante identical merchants selling a homogeneous product through a sales intermediary. And we discuss multiple merchants in the extension. Well, we assume a fixed and exogenous proportional fee that is strictly between 0 and 1. This is justified by the observation that some platforms have been keeping their proportional fee scheme for a considerably long time and are expected to continue their policy in the foreseeable future. So examples come from the app stores, which have been charging a 30% enumeration from the app developers, and Meituan, which is a food delivery company, and charges a fixed proportional fee for merchants. In the extension part, we also discuss per unit fee schemes. For simplicity, we abstract away the production cost in our main model, although we allow for some simple form of production cost in the extension. Now, as for consumers, we assume consumers with unique demand have identical preferences for the product. But we discuss heterogeneous consumers in the extension, so we assume consumer valuations, gross valuations R, but they would have some negative search cost, which is less than R, if they buy from the merchant not recommended by the intermediary. So just a simple illustrating example. Suppose merchant 1 got recommended by the intermediary and posts a price P1, and merchant 2 posts a price P2. And then the consumer utility is just R minus P1 if they buy from merchant 1, and it's R minus P2 minus C if they buy from merchant 2. And then they got 0 if they buy nothing. So we just normalize also option to be 0. There's some tie-breaking rules to make our model complete. Consumers will purchase if they are indifferent between buying a unit of product and buying nothing, and consumers will purchase on their initial visit if they are indifferent between buying from the merchant. As for the intermediary, it will make a recommendation that maximizes social welfare if it is indifferent between recommending either merchant, and it will recommend either merchant with equal probability if either way yields the same amount of social welfare. So the social welfare or the welfare of other parties just enters into the welfare function of the intermediary in a second order sense. It's not in the first order sense. And a remark is that our main results will be qualitatively unaffected if the intermediary makes a recommendation that maximizes social welfare or maximizes merchant profits and then consumer welfare, or recommend in the merchant with equal probability when very different. So our result is robust to different tie-breaking rules. Now let me briefly show the equilibrium predictions. The equilibrium consists of the strategies of the merchants, the intermediary, and consumers solved by the backward induction. Our remark here is that we can assume that each merchant sets its price no greater than R, and this is without loss of generality. So 2 lines proof. Any price greater than R is never a best response to any price set by its competitor when the search cost is positive, and it cannot be part of the equilibrium when the search cost is 0. So this has some policy. This has some welfare implication. This means that each consumer will always buy a product because they will get a non-negative welfare. They will get a non-negative payoff if they buy from the first merchant. So this is already would be better than buying nothing. And this means that player strategies can only affect the distribution of social welfare, but not the amount of everyday social welfare. Now the first lemma intuitively is on the consumer strategies. So this is quite straightforward. Consumers, upon an initial visit to merchant I, which is either 1 or 2, and observing both price quotes, they will purchase from the merchant I if and only if the price submitted by merchant I it does not exceed the price submitted by the other merchant plus the search cost, and vice versa. So, but the key findings come from our second and third lemmas regarding the intermediary and the merchant strategies. So now let's move to the intermediary strategies. Instead of going through the words, I will just graphically show the results. So here's a graph that shows the intermediary strategies. In the shaded areas, the intermediary will recommend merchant 2, whereas in the white area, the intermediary will recommend merchant 1. So let me explain the rationale. So suppose we have a price observed in the upper shaded triangle. So which means that the price submitted by merchant 1 is strictly higher than the price submitted by merchant 2 plus the surge cost. So in this case, no matter what merchant got recommended by the intermediary, the consumer will always buy from merchant 2. This pins down two cases. Case 1, merchant 2 is recommended. I see a comment in the chat box. Let me see. Total social welfare is so my brief comment to my response to this to the question by Eva. I hope my pronunciation is correct. The social welfare can be affected off equilibrium, but it turns out that once the consumers are rational, if consumers are rational, then our result would predict that all consumers will buy from the recommended merchant, and in equilibrium, no consumer will buy from the other merchant. So on equilibrium path, the social welfare remains unchanged. But it's true that the social welfare can be changed off equilibrium paths. Yeah. So I guess maybe maybe I should make it more precise here. Social welfare is unchanged on equilibrium paths. So now let's get back to this figure. On this upper triangle, there are two cases. So the case 1 is that the intermediary just recommend the cheaper merchant, and in that case, consumer will definitely buy from the merchant 2, which submits a cheaper price because that saves their money and saves their search cost. Case 2 is that the intermediary would recommend merchant 1, but in that case, consumer will still search and pay for the search cost because the cost differential between these two merchants is higher than the search cost. So they would rather search and buy from the non-recommended merchant. Given that our tiebreaking rule assumes that the intermediary will recommend a merchant that maximizes social welfare, then it will recommend merchant 2 in this upper triangle. But the story is slightly different in this trapezoid. In this case, the merchant still recommends merchant 2, but for a different reason. In this case, no matter what merchant gets recommended, consumers will always buy from the recommended merchant. This is because the cost differential is strictly smaller than the search cost, such that consumers would not like to pay the search cost in order to buy from the other merchant, even if the price of the other merchant is slightly lower than the price of the recommended merchant. So in this case, in order to maximize its own profit, maximize the profit of the intermediary itself, then it will recommend the merchant that price is slightly above its competitor. So in these two cases, the intermediary will recommend merchant 2, but with slightly different rationale. And by symmetry, the similar rationale applies for the areas in its white areas, in this lower white triangle and in this white trapezoid. And it remains to show the results on these three lines. On this red line, then the intermediary would just randomly recommend a consumer because both merchants submit exactly the same price. And our tiebreaking rule, if we just go through, I see another chat. Oh, okay, no problem. So on this diagonal line, because the prices by both merchants are the same, then the intermediary will just randomly recommend a merchant based on our set of tiebreaking rules. On this black line, the intermediary will still recommend the merchant 2. This is in this black line, the intermediary will recommend merchant 1. This is because the price of merchant 1 is exactly the search cost plus the cost by merchant 2. So in this case, the intermediary will recommend merchant 1, and consumers are exactly break even. But given our tie-breaking rules, they will purchase from the recommended merchant. So the intermediary will recommend the merchant that price above its competitor in order to get a higher profit. And similar rationale applies for the blue line, in which case the intermediary would recommend merchant 2.
And
yes,
just to make sure, this is sensitive to that tie-breaking rule on whether the consumer continues to search, right?
Yeah, it's true. Yeah, we need some slight restrictions on the tie-breaking rules, but we can have like we can have different forms of tie-breaking rules like we showed there. Of course, there must be some minimal restrictions on what the intermediary would do in order to like recommend a merchant. It's not assumption free, and it's not come freely, but we show that it can take different forms, and yeah, it can take different forms, and the intermediary can have different second order incentives. So they can wait.
For example, if the tie-breaking rule was 50-50, 50% of the time you continue, 50% of the time you don't. Tie-breaking rule for the consumer is what's worrying me right now. If there were a different tie-breaking rule for the consumer, would you not have those lines then, or would they just be in a different location?
If they have 50-50 on consumers only.
Right, because if I'm understanding it, it's the tie-breaking rule on consumers that matters for those lines. I could be mistaken here. Right?
It can be driven by the consideration on consumers, but it can also be driven by consideration on merchants. Yeah, it can come either way. So let's just can move to that slide. Tie-breaking rules. So tie-breaking rules are. So sorry, let me get out there.
You can also leave this to the end. There will be about 10 minutes where we can just kind of have a Q&A if it helps with the flow.
Oh, okay. Tie-breaking rules. Okay. So basically, we allow for the intermediary to like have a second order consideration on social welfare or consideration on like here on consumer welfare or merchants profit and then consumer welfare. So we can have different forms of tie-breaking rules. But it's of course it's not purely random. It has some kind of restrictions. Yeah.
I'm more the indifferent of if the consumer has 2 equal value products, they don't continue search. That's more where I think your result is going to be sensitive to that tie break.
In that case, basically we assume that the intermediary must recommend a merchant. It cannot just so it has to be a strict order. Merchants must be ranked in a strict order. So this is justified in the like real world examples, such as the website. We have to scroll down from top to the bottom. So there must be ex post. There must be a strict order. Although the intermediary can like be indifferent and do like different randomizations ex interior or ex ante. I'm not sure whether
I'll follow up at the end with this.
Okay, no problem. Yeah, we'll get back to your question in the end. Then finally, we move to the merchant strategies. So it breaks down to broadly 3 cases. When the search cost is exactly 0, then our model is coincides with the standard Bertrand argument, and the unique prediction is the competitive equivalent. But the story becomes different when the search cost is strictly positive. Then it boils down to 2 different cases. So in case 1, the search cost is significantly large, and this in particular is at least equal to half of the consumer valuation of the product. In this case, when the competitor charges a price that is lower than or equal to the consumer valuation minus the search cost, then the best a merchant could do is charge a price that is equal to the price of the competitor plus the search cost. Because in that case, the merchant would get recommended for sure and would get as much higher profit as possible. It cannot charge even higher because in that case, consumers will not buy from that merchant. But if the competitor charges close to the consumer valuation, then this merchant can no longer charge that high. And the best it could do is just price exactly equal to the consumer valuation. The interesting case comes from the case where the competitor charges exactly equal to the consumer valuation. Then this merchant has two options. It could either charge also equal to the consumer valuation and split the market with 50-50, or it could steal all the consumers by charging a price that is slightly below the consumer valuation minus the search cost. When the search cost is sufficiently large, this merchant would be better off to just split the market because the amount of undercut needed would be significantly high. When the search cost is not too large, then this merchant would rather do the undercut and steal all the consumers. So that boils down to two cases. In this case, we can see there's an unique intersection of two bias response curves. So that leads to the collusive outcome. Whereas in this case, the two bias response functions have no intersection points, and there's a discontinuity at this upper right corner of this box. So that means there's no pure strategy equilibrium when the search cost is within this broad range. So this slide summarizes our findings so far. And we would like to do a little bit more to show what would happen when the search cost lies in this broad range. But to do so, we have to rely on some ad hoc assumptions here. We try to make it. We try to solve this model using like continuous price framework, but it turns out to be analytically intractable even for the simplest form of interval strategies. So we are able to perform exact form analysis in that case. So we do some ad hoc assumptions on the price space. We just discretize the price space by assuming that there's a smallest currency epsilon such that prices must be a multiple of epsilon, and then we let this price grade to converge to zero. So if anyone here have any thoughts on like how to deal with the continuous price space with a discontinuous bias response curves like that, so we are more than welcome for your comments on this, and we're eager to see what would happen in that case. So in this ad hoc version, our model better fits to the scenario where the mass of consumers is sufficiently large, or the consumer valuation is sufficiently large. In these two cases, our limiting case would be a better approximation to the real world. So based on this discretization of the price space, we find a circle between the three prices. We find that the price at consumer valuation is the bias response to the price that is slightly below the consumer valuation, and that price is the bias response to the price that is slightly below the consumer valuation minus search cost, and this price in turn is the bias response to the price at the consumer valuation. And we would like to see whether there exists a mixed strategy equilibrium that consists of these three strategies. And if so, we would like to calculate this mixed strategy equilibrium. We omit the calculations here and just present our final results. So it turns out that when the search cost is intermediate, meaning that it exists a threshold between 0 and R/2, but but it's less than R2, then the mixed strategy equilibrium would exist. And it turns out that we got this. So after some limiting argument by letting this price grid to converge to 0, then we have something simple that is summarized into this 2/3, 1/3 pricing rule. So it turns out that in this mixed strategy subgame perfect Nash equilibrium, when the price rate converges to 0, then each merchant sets the price around the monopoly price 2/3 of the time, and sets the price around the monopoly price minus the surge cost 1/3 of the time. It turns out that these two probabilities are independent of the proportional fee scheme, consumer valuations, and the surge cost. So our remark is that this equilibrium is close to the collusive equilibrium, but far from the competitive equilibrium, which adds robustness to our results by allowing for a moderate upfront cost for each merchant to set up their businesses. And this table summarizes our welfare results. The welfare analysis for the two pure strategy equilibrium are straightforward. When the surge cost is 0, the consumers got all the welfare. When the surge cost is strictly high, then in the collusive outcome, the merchant and the intermediaries split all the welfare. But when the surge cost is between this range in that mixed strategy equilibrium, then each party gets some welfare, and it turns out that by taking the derivative of these three formulas, we find that consumer welfare would be higher if the surge cost is lower. Consumer welfare is higher if the surge cost is also higher. Yes, sorry about that. So and the converse is true when the surge cost is lower. So this is somehow a result that is counterintuitive. So our model suggests a non-monotonic relationship between the consumer surge cost and each party's welfare. When the surge cost is intermediate, consumers are worse off and merchants are better off when the surge cost significantly increases. But the opposite is true when the surge cost increases locally. So what does it mean? So it means that if the surge cost, let's say the surge cost is originally exactly equal to C hat, then a small increase of surge cost such that the resulting surge cost is still within this range would make consumers better off and make the intermediary and merchants worse off. But if the amount of surge cost increase is significantly large, such that the resulting surge cost goes to this range, then the consumers would be driven out of all the welfare, and they will be worse off. But the other two parties are really better off. So this finding suggests that to evaluate the effectiveness of policies related to the consumer surge cost, we might need some empirical evidence to see where the surge cost comes from and what the resulting surge cost would be after we launch a policy as such. So let me see how much time we have. We have 4 minutes. Let me briefly talk about some maybe one extension and then conclude. So in extension 1, we allow for the per unit fee schemes. So again, our results on the per unit fee schemes are sensitive to the tie-breaking rules, and in fact, it's driven by the tie-breaking rules. If the sales intermediary cares more about consumers than about merchants, then it will always recommend the merchant that charges a lower price. This is because no matter what merchant got recommended, they will generate a sale, and the intermediary will collect that fixed amount of sale. So in this case, the incentives between the intermediary and merchants are not perfectly aligned, but independent, as long as the price is within that range. So in this case, if the intermediary cares about consumers more, then the competitive equilibrium outcome will happen. But on the other hand, if the intermediary cares more about the merchants than about consumers, Then as long as this per unit fee scheme is not too large, our qualitative results in proposition 1 still follow, because under this assumption, then the incentive between the intermediary and merchants are again perfectly aligned. But given that there are only 2 merchants by the mass of consumers, allowing for the side payment would make the outcome that that aligns the interest between the intermediary and merchants more likely to happen, because that kind of side payment is easier to make given the limited amount of merchants but mass of consumers. So our results are still reasonable under a per unit fee scheme if merchants can pay for a side payment to the intermediary in order to have a more favorable tiebreaking. We have 2 minutes. Let me just conclude without talking about the other 2 extensions.
You actually have 4 minutes. We started 2 minutes late.
Oh, 4 minutes. Okay. Then let me talk about extension 2 in 2 minutes and then conclude. So in this extension, we allow for the consumer variations to either uniformly distributed over 0 to R or have a more general distribution. In this case, under the uniform distribution case, we have a stronger result that is analogous to our main results that is shown in our 2 propositions. But our remark is that there's no issue of the double marginalization that is commonly found under a volatile structure, because in our game, the merchants are ex-ante identical and the intermediary has a strong market power. So it can internalize the cost. It can internalize the pricing of the merchants into its strategies and extract all the industry welfare. There's no issue of the double marginalization that reduces the pie of the market. I see a question. In the extension, do consumers know their valuation before their? Yes, each consumer know their own valuation as well as the distribution of the valuation. So there's no informational friction in our game. We just assume everything is publicly known to every party. If we allow for the if we consider a more general distribution F, then under some restrictions, then we still find that there exists proposition 1 still follows firstly, and the proposition 2 regarding the mid-strategy equilibrium, it also follows when the search cost is less than a threshold and is sufficiently close to that threshold. So our result hold for a general distribution in a qualified way, but if we allow for the distribution to take some parametric form, then we believe that we could get some stronger results than this pointwise result. Let's see another. Oh, okay, no problem. Let me see how much time. 2 minutes. 1 minute for this. 1 minute conclude. Last extension. In this extension, we consider multiple merchants, but it turns out that the mid-strategy equivalent drives away in this case, because consumers can always deviate to some price. But our proposition 1 still follows. That is to our characterization of the 3 possible equilibrium types still remains true when there are multiple merchants. So our remark is that the threshold changes when the amount of merchants changes, and the exclusive equilibrium is harder to sustain when there are more merchants. So this result is not surprising, and is analogous to our standard, our conventional wisdom on the collusion between the merchants, between the number of merchants and the price. I have 1 last minute. This paper studies the phenomenon of price dispersion in the setting of indirect sales with search cost. We propose a model in which identical merchants compete via a monopoly sales intermediary. 2 key assumptions. Consumers know the prices of both merchants before their visits, and consumers do not need to incur a search cost if they buy from the merchant that went first, but will do so if they would like to buy from the other merchant. Our key results are that the value of the search cost crucially determines the type of equilibrium and each party's welfare. And when the search cost varies, 3 different types of equilibrium can happen. When the search cost is intermediate, then we find a mid-strategy equilibrium with fixed proportion, with fixed probability assigned to the 2 prices. And perhaps surprisingly, higher search cost will benefit consumers, but hurt both the merchants and the intermediary. Our model can explain the puzzle that merchants can sustain a positive payoff even when they are exactly identical and sell a homogeneous product, and consumers are also homogeneous. And our results can also extend the path of price dispersion in this setting. Finally, our findings are applicable to many areas of businesses, such as online platforms and the travel industry, and have implication on policies related to consumer search costs. And that's the end of our presentation. And we are grateful to many experts who come for today's talk and raising excellent comments, which will significantly benefit for our work. And thank you. We welcome other comments in the remaining time.
Thank you for a great presentation. I now open it up to questions. So I actually have one. No one jumps in.
Yes, please.
So you're in a world where basically everything is known. Is the cost of going from the first firm to the second firm really a search cost, or is it really a switching cost at that point?
That's a fantastic question. Actually, in the beginning of our work, I just call it a switching cost. But later on, when I presented this work, I got some comments from some audience who were also in this area, and we got the comments from the audience to change the terminology of search cost to switching cost to search cost, and we just followed that advice in our revision. But frankly speaking, since we don't know exactly how these 2 terms are defined in their in the actual settings. So if you
I mean, I think some of it's more like the art form of defining things, but it kind of led me to think that when you were going to go to heterogeneous values, that the search would at least be over those heterogeneous values, versus when you move to heterogeneous values, it still was all known prior to search. And I think in that world, at least to me, it's more of a switching cost, but it's just a personal opinion.
So what we got from the comment is that the switching cost refers to the case of repeated purchase, and our setting is one shot. So this is what we got, but
I guess I should say it's not really the information cost.
Yeah, it's not the information cost. Exactly. It's frankly speaking, we are not sure which terminology works better. But this is what we are doing now. If any, let's say, any audience or any expert have like precise advice on this, just let me know, and we would we're grateful for that and see which terminology works better. Yeah, and definitely for them, we will maybe we'll seriously consider your advice and see what the literature how the literature defines like search cost and switching cost and how they differ. Yeah. Thank you.
I have a comment.
Yes, please.
So I have a comment which is partially also kind of an advertisement of my paper, which was co-written with Martin Jansen. So unlike your paper there, we have, instead of intermediaries, buyers who already made purchase, and therefore they can recommend sellers or merchants to the buyers who have not made purchase. And there we have a result similar to yours, which is as the search cost goes up, the expected price paid by the consumers goes down. So in a sense, it benefits consumers. Of course, the entire mechanism is totally different, but just wanted to recommend to take a look at it maybe.
Oh, that's great. That's great. So I'm not sure whether I got exactly the paper, but I would be very grateful if you, like, say, just send me the link, and I will take a look.
I will.
Yeah, or maybe like by chat or by email. Either way is fine. Yeah, we'll
Sure.
take a look.
I will email you.
Yeah, thank you very much. So our comment, just a brief comment following the question by at the back. So far we only found this paper on so far we only found one paper that shows that that consumers can benefit from a higher search cost. That is by Martin Jensen and Zhou Schleicher. Both of them are here. But if there are any other papers that that show this result, then we're definitely we would definitely like to take a look and see whether the mechanisms are similar or different, or whether they have like additional insight that we might be able to incorporate into our work.
So kind of going to the heterogeneous values version of your model.
Sure.
Did you consider something like logit at any point? Just because, you know, at that point, you've just got heterogeneous values that are known prior to any search. Prices are known prior to search. And so essentially what your price is going to affect is your quality. If you think about, you know, whatever firm goes first, essentially is just given an advantage, which is just flipping around that the second firm is given a disadvantage. If you considered solving just the kind of logit duopoly version of this?
I'm not sure whether I got the point. Do you mean the distribution follows logit, or?
Yeah, so if you made the valuation of the first product and the second product, both of those products follow logit. I realize, are you assuming they have the exact same value here, or?
So here, here we just we assume that the products are still homogeneous. That means that consumers have the identical valuations to the products by both merchants. Yeah, but the distribution of that value. So there might be like 3 consumers. One has like 10 valuations, and another has 8 and 6. That distribution has some form. So here we do not impose any parametric assumptions, and we still got some results. So that kind of add robustness to our finding, because even without any parametric assumption, we still could get some despite qualified results of both proposition 1 and proposition 2.
So, but you've got heterogeneous values, but the values are all the same. So there's still going to be the idea of kind of indifference over searching the next product, then, because they'll all have the same search cost, I assume.
Yeah, a slight difference is that not all consumers would be included in the market. So there might be some consumers who opt out of the market. But the strategies have a similar flavor, because still they are ex-ante identical. Everything is ex-ante identical. So and the intermediary would still like to maximize its own profit. So most of the results follow, except that some consumers will not purchase. So that's a slight difference between the extension and our homogeneous consumer baseline model. Yeah, of course we need some restriction on this F. It's not coming out of free. Like we need some kind of uniqueness assumption and concavity assumption, something like that.
So I think going back to that earlier tie-breaking thing that I was
Sure.
asking, just to be clear, I'm not at all asking about the platform. I'm purely asking about the consumer. If the consumer is indifferent, you assume that they take the first recommendation. Now, if there is any other tie-breaking rule, you'll get a different answer in your model, unless I'm mistaken here. Because essentially what's going to happen in equilibrium is there's going to be indifference, and the platform is going to take advantage of that by putting the firm that benefits them first in that indifferent setup. And,
exactly.
And but that matters, because if it was 50-50, an equal rule, you'd get a very different result. So if a consumer is indifferent between searching the next product, and the tie-breaking rule there for that consumer is half the time you continue and half the time you don't, I'm pretty sure you're going to get a very different result. And it does worry me that it's a little sensitive to that tie-breaking rule.
Consumers. If consumers are indifferent between buying from either product, then assuming that the search cost is not zero, so because if the search cost is zero, then that's trivial. So assume it's positive, then it will happen if and only if the price of the recommended merchant is exactly the search cost plus the price of the other merchant. So that happens exactly at that case.
So if the price of the firm that's listed first is $1,
okay,
right, and the search cost is a half, and then the second price is what, a half. Sorry, morning. The consumer is completely indifferent over continuing, right? Now you assume then that they don't continue.
So, I see.
I'm just concerned that your results would be very different if there was a different tie-breaking rule on whether that consumer continues.
I see your point. So
that's the tie-breaking rule that's worrying me.
Okay, I got it. So an ad hoc justification of this tie-breaking rule is that consumers would have higher order processing cost through the list. So it can come like in a form of like a manual cost. So that's not non-monetary, but if a consumer decides to like scroll down there with their mouse from the first result to the second result, then it will have to process this. It will have to go through this process in their mind, and it can be associated with a higher order manual cost. So and it's natural to assume that consumers, when they browse a website, they'll go from top to the bottom because sometimes it's even impossible to go through the bottom to the top when the bottom one is on the second page, or if there's some like advertisement that that consumers have to like click off and then buy from the other one. So it's true that if consumers like have some like kind of trembling or a small probability to buy from the non-recommended merchant, even if it didn't get if they are indifferent, yes, the result would be, I think the result would be different. I'm not sure whether this ad hoc assumption is enough or not, but so far I just as far as I know, I just came out of this very ad hoc assumption. Maybe I should search for more formal results in related literature to justify our tie-break rule on consumer side. Yeah. So thank you for raising this concern. It definitely has some effect on the results. I think so.
Thank you. I'm going to end the recording here, but everyone can keep asking questions if they want.